Okay, so I want to talk a little bit about functions. This is section 2.1. I want to just do a little bit of an introduction to functions and domain and range, which are important function concepts. So we'll start with just sort of a quick little definition. A function is a mapping of values from one set, which we call the domain, to another, which is the range. We'll think of this a lot of time as sort of an input and an output. You kind of put a value in, you have like a starting point, which is a value in your domain, sort of as an input. And then you end up, mapping or sort of going to a second point, which would be an output value, which is your range in the range. A lot of the times what we're going to be doing, we'll be sort of visualizing these functions and doing different things. So usually our domain values we'll think of as x values, and the range values we'll think of as y values. So we will, we won't use those sort of interchangeably necessarily, but almost always our domain values will be x values and the range values will be y values. So these will be essentially x's getting synced up with, right, and sort of associating with different y values. So we can essentially represent a simple version of a function just by like listing some ordered pairs, right? So just pairs, x, y. This gives us a way, right, to sort of show the connection between them, right? The sort of link from like one to the other, from a domain value to a range value. A function is, right, again, this kind of a mapping, this sort of association of sort of a set of numbers to another set. So if I list some individual pairs, right? So in this case, 3, 6, 4 minus 2, right? Sort of 1, 0, and 2, 4. The idea here, right, is so the 3 sort of maps to the 6, the 4 kind of maps to the minus 2, the 1 kind of maps to the 0, and then the 2 sort of maps to the 4. And so what I can do from this pairs, I can essentially just pick out all the domain values and all of the range values. It's not really anything more complicated than just sort of listing, right? The domain values are just all of the individual x values, and the range values are just all the individual y values, right? So my domain here would be the x values. These are sort of out of order. It doesn't particularly matter, right? 3, 4, 1, 2. I could write them in order, 1, 2, 3, 4. It doesn't particularly matter. My range values, right, would be all the different y values that I have here. So kind of 6, minus 2, 0, and 4. You could rearrange them into order, right? Negative 2, 0, 4, and 6. It doesn't particularly matter. Knowing just the domain and the range values kind of by themselves doesn't really tell you what the actual correspondences are, right? You would still need these pairs to kind of know which value goes where. The idea here, so there's sort of one restriction, so that is to be a function, every domain value, every x value, right, can only map to one range value, right? So the idea is this is kind of a unique mapping. You're sort of taking every x and it can only go to one particular y value. You can actually repeat y values. That's okay. You could have 2 different x values go to the same y value. That kind of a doubling is fine. You just can't have you can't have an x value go to 2 different places. You could kind of think of these almost like you're giving directions, right? So you're telling an x where to go. And so you can't tell one x value to go to 2 different places. You can't have an x that goes to positive 2 and negative 2. It doesn't work as a function. The function has to be sort of a unique mapping. So if you're giving somebody directions, you have to tell them to either go left or to go right. You can't sort of tell them to go left and right at the same time, right? It doesn't make sense. So if I listed another sort of set of values here, right? So pairs 5, 2, 3, negative 4, 1, 2, negative 3, negative 4. This is okay. This is still a function because all the x values are unique, right? 5, 3, so 1 and negative 3. There are some repeats in the y values, right? The range values here, I sort of am doubling up. 2 shows up twice and the negative 4 shows up twice. That's okay, right? So if I'm thinking of this from the x perspective, every x has a unique place to go. Every x sort of has directions and sort of knows where to go. It will go in some sense, some of them will go to the same y values, but that's okay. It's not about, only one point can take a left turn, only one point can take a right turn. You can have more than one x value take a left turn. It's just that you can't have one x value go two different places. So this is okay. This is still a function. We just have a little bit of a smaller range than a domain. If anything, right, that's possible. The thing you couldn't have would be a smaller domain and a bigger range, because that would kind of imply that you had x values going multiple places, which would sort of break our definition. What would something that's not a function look like? Well, as pairs, right, it would be sort of 2 minus 4, negative 2, 5, 2, 6, and then 4, 3, right? So the issue here is the 2 shows up twice in the domain. That there's any kind of repetition in your x values that's going to sort of break this as a function, and it won't be a function. You could call this a relation, which would be sort of the same kind of idea, but with less rules, essentially, right? Just sort of making pairs, x's and y. That would be a relation, but it wouldn't be a function, which has this sort of extra definition of every x can only go to one unique y value. Page 2. Often what we're going to see is a function written out kind of like a formula, where we'll have some sort of equation or sort of formula that kind of tells us the mapping in one line, rather than having to list out all of these individual pairs. Like I said before, with a simple function where you only have a handful of points and sort of mappings, you can kind of just list them all out. But in general, what we'll have is something where you could sort of map some big set of numbers, right? All the positive numbers, all the negative numbers, just all of the numbers that there are. In which case you don't want to have to write out, it would literally be impossible to write out every single individual point. You would need instead to sort of have some sort of formula that sort of tells you what the mapping looks like. So our notation for that is this. It's sort of f parentheses x. What we say is f of x. So f, I suppose, obviously for function of x, right? Because x is going to be your sort of input value. X is your domain value. So the idea is you're sort of putting this x value into some sort of formula. So what that might look like, I sort of just did a quick little example of a formula that would look like one of our linear equations, like what we were sort of doing in 2.3 and 2.4. Excuse me, this has a sort of mx plus b kind of format, right? So f of x, which is our sort of function expression, is equal to negative 2 times x plus 3. So what this is telling us is, right, we're sort of going to pick an x value and we're going to sub it into the formula for all the x's that are there. So in this case, this should have sort of a linear relationship. This is something that we could sort of visually represent with a graph that would look like a line. But individually, if we want to just sort of find individual mappings, you could sort of pick, in this case, pretty much any x value that you wanted to, and put it into this formula and sort of get a range value coming out, which would be like a y value. So the idea is, so for example, let's say we pick x equals 2. So what you're going to do is you would say f of 2. So 2 goes into your parentheses and replaces the x. And then the same thing in the formula, right? So I have my sort of 2 in green. So anywhere I have, right, the x in parentheses, anywhere in my formula where there's an x, I'll put it in. And you could have more complicated formulas, polynomials or something, where you have more than one x. You could do square roots. You could do all sorts of different things that we've sort of seen before as equations. So all that stuff is in play. For now, we'll just do this sort of quick linear one. We'll just run one of these fast, right? So if x is 2, you're subbing 2 in here. And then we just sort of do the math, right? Negative 2 times 2 would be negative 4 plus 3. Negative 4 plus 3 would get me a negative 1. So the idea here, right, is I started at the x value positive 2, and I sort of put it into this formula, and I ended up at negative 1. So this is sort of x is 2, and then my y value would be negative 1. So as a pair, right, I'm ending up with this sort of ordered pair 2, negative 1. And I could essentially do this for any x value that I wanted to. The next video is about evaluating functions, which is doing just that. So you can put all sorts of different numbers into here, or you can do stuff that's a little bit more abstract. You can actually put other sort of algebra formulas in, and you can sort of make different kind of combinations of different things. But we'll save that for the next video. This is just the introduction.